Thanks for watching. Here we go, like I promised. So here is jumping into law of sines, which is side-side angle, which possibility of having one, two, or no triangles. If obtuse, it could be one, zero triangle, or two triangles actually, we found out in second period. Let's see here. So these are our possible answers, especially for number 1 through 6. But before we do, talk about the debate, Paddington Bear versus Winnie the Pooh. Oh man, I couldn't find any videos like I tried to for you guys, but couldn't find any. So, Paddington represents the Freudian concept of superego loves marmalade, which contains all the vitamins and minerals. Pooh Bear covets honey, which is gluttonous bee excrement, no nutritional value. Dawn of Justice, Pooh versus Paddington. So, Paddington Bear would obviously physically overpower Pooh, but he would never fight him. And Paddington would offer him some marmalade and kind words. So I don't think there's really going to be I think they're just both going to get together with the Avengers and take out that teddy bear called Ted who has a bad mouth. Anyways. Okay, so looking here. So either 0, 1, or 2 triangles. In class we talked about number 5, and 6. And so number 6, we have our largest angle. Is 145 degrees, and so then our largest side is not 29 meters, it's only 21. So this angle with this matches side does not exist. So D does not exist, right? Does not exist. There we go. So that kind of settles that little debate there. So that's for an example of 0 triangles for number 6. I also wonder if we tried out our calculator if it wouldn't work either, right? So let's say we're just trying to find so you always want to try to find the angle opposite the one that's given. And so let's say try to find angle B. So what we would do there is we would go ahead and do sine of B over 29, because the side they give us for little b is 29. And then we'll set it equal to, let's see here, so then sine of 145, which is they give us, and then over 21. And then we would multiply 29 to the other side to solve for angle B. And then we'd go to an inverse sine, right? Inverse sine both sides. So I wonder if you get an error in your calculator or not, or if you just have to logically know that that triangle doesn't exist. So in previous videos I watched, they said you'd get an error, but let's see. So 29 sine 145, close parenthesis, divided by 21, good. So just using the law of sines right now. And so we do get an angle, but I don't think I did it right, or it doesn't exist anyways. So sometimes we have to be smarter than even our calculator, so I don't always rely on that. You just have to realize that if they have a large angle, you should have the largest side. Otherwise it does not exist. Or if you get an error on your calculator, it does not exist. But let's take a look at number 1 together. So this is how I would draw the triangle always, just like this, to give you some room to swing that leg. What do you mean? You'll see. So we're going to label this as angle B, and they give us this 56 degrees. And then, let's see here, A we don't know, or you can call, oh yeah, they give us A, so we don't know A, which is the angle opposite the one given. But we do know what little a equals, which is the side length, opposite angle A. And then we can go ahead and do this. And so this is, wow, that wasn't even straight. Let's try that again. Okay, we'll use this, and we'll use this, and we'll use this. And maybe even that. Could be that. That might be fun. How about that? Sure, why not? Okay, so then we'll swing that leg, dozy-do. What? Okay, so here's our given leg, right. Here's our given leg. And there we go. Now to really make this really work for us, we probably want to swing it out a little bit more if really possible. I know I'm getting kind of detailed here. But you'll see in a second. So make that angle a bit bigger and this one a bit wider. Awesome. So we'll move this over here. Good. There we go. Okay, so then you'll see. So what we're going to do now is we're going to go ahead and see if it's possible even to get A. right, using the law of sines. So they do give us, here we go. So they do give us what opposite of big B, 56 degrees, the given angle. They also give us the side length. That's great, 31 meters. There it is. So then we make sure we don't get an error in our calculator, because that means 0 triangles. If you did it right, you got to make sure you did it right. So we'll go ahead and do, we're trying to find angle, so we'll do sine of angle A over little a, 35, because 35 might be too big, we'll see, is equal to, and then we have sine of 56 degrees. Maybe move that over a little bit to leave some space there. So sine of 56 degrees all over its opposite side, 31. And now we're going to go and multiply, right? So we'll go to multiply 35 to the other side like this. And then to undo sine, we're going to inverse sine. And so now we're going to go and do the inverse sine of this whole thing. And that'll give us what angle A is. Nice. So plug that in your calculator. So inverse sine of 35 sine 56, close parenthesis, divided by 31, close parenthesis. And then that gives us an angle of 69.3 or 69.4 degrees. Okay, so if this is 69.4 degrees, good. Is this triangle a possible triangle? So 69.4 degrees looks like it's going to be possible, because now we go and compare that to 180. So is it greater than 80 or less than 180? So if it's less than 180 degrees, then awesome. We should have another triangle. So let's go and give that a try. So now we want to do, to find, what is that called? What are we missing? Oh yeah, angle C. So to find angle C there, we're going to go ahead and do 180 degrees minus the angle we just found, 69.4 degrees, and the angle given, 56 degrees. And so that's going to give us angle C, our third angle of this triangle. 180 minus 69.4, good, minus 56, so that's 54.6. So cool, we have an acute triangle, 54.6. And so that's, we can say we have one triangle so far. Cool. But you mean there might be another one? Oh, no. Yep, there might be another one. So we have to rotate this leg now. Watch this. We're going to rotate this leg. And guess what? It might have been set up to be an acute triangle, but it also could have been set up to be an obtuse triangle. See that? So that's a really bad drawing, but we'll draw it better down here. What do you mean? So let's see if we can show you what I mean. Okay, so now we have this side length still, which is 35. So I should have done my drawing a little bit better for swinging purposes. Should have been more like this probably. Probably less this and more that. Oh, well thanks a lot, new build. Sorry. Let's do it a bit better, because I really want to make this look beautiful for you. So we're going to go ahead and change this guy again. And let's go and raise this just a little bit. That'll be hopefully better. We'll see. Okay, there we go. So there's our 69.4 degrees that we found from before. We're going to go ahead and make this now actually a little bit smaller. There we go. So now when we go ahead and flip it, or why don't we just make a copy of it? Yeah, let's make a copy. And then, oh no, clone. Yeah, clone it. Okay, so that same, there it is. So that same distance, can you see it now? Can you see it now? How about me now? How about me now? Oh, there we go. So now we have an isosceles triangle. What the? So again, this is 31. And if that's 31, then this is 31. Oh, okay, I'll go with you on that so far. Okay. Well, that means if that's 31 and that's 31, then that probably means that the angles are the same. So if this is 69.4, that means probably that what? That yeah, it's a isosceles triangle, which means the angles will also be the same. So that's 69.4. And now we've got this obtuse triangle going on, which we'll draw down here, with this being 56 degrees, and then this being something. What is that something? So that something is, if this is 180 degrees, if that's 180 degrees, then that means, right, if this is 69.4, then that means that, that's awful looking. Sorry. So that means that 180 minus 69.4 is going to give us an obtuse angle of our other triangle. Really? Yeah. So minus 69.4, so that's 110.6. So that means that this is 110.6 degrees, and we have another triangle. And so now we've got to do 180 minus both of those to get that really, really, really small angle. So 180 minus 56 minus that 110 we just found of a big wide obtuse angle. And so that's going to give us the 13.4. So now we have another angle C, call it angle C prime. And so that's what they usually call it there, probably because of transformers, right? What are you talking about? You know, Optimus Prime. So we're going to call this B prime. This will be B prime, or just B, or B prime. And then this one will be, what's this one? What's this one? So this one was our original angle, which was angle A. And so this will be A prime, C prime, B prime. Cool. And what was that angle again? Oh yeah, 13.4 degrees. So now we have 13.4 degrees. Cool, cool. And now we have two triangles because we have a second triangle. There's another triangle over here. And so 1 plus 1 is 2. So this problem, the answer will be two triangles. Cool. So there's our answer there. Awesome. We did the same thing with number 5, except for with number 5 in class during second period. Yeah, go second period. Name drop. So for second period, we went ahead and we did the same process. And we actually found that we had two obtuse triangles. We had one with 28 degrees, 36.86 degrees, and then 115.14 degrees. And then we found another triangle with 8.86 degrees, 28 degrees, and 143.14 degrees. So we had two obtuse triangles. What? That was crazy. Cool. Oh man, look at the time. I gotta go. Awesome. So basically for 1, 2, 3, 4, 5, 6, you're supposed to just go ahead and state the possible number of triangles that can be formed. And so we'll jump over here to the answer key to the odds at least. And so number 2, go and figure it out there. So number 2, because it's already an obtuse triangle, we can't swing the leg and make it a acute triangle or another obtuse. So that's why it's only one triangle for number 2. And cool. So make sure that you keep looking at this video. I'm telling you what, odds, just to help you. Okay, so then when we go to these ones, you actually have to solve both triangles. Get them both and solve them both. So for example, number 7 is definitely one. And it's basically just the same process. So I'll try to do it really quick now just to show it to you. Excuse me. Okay, so then we'll go ahead and draw that triangle again. So 71 degrees, they call it angle B. Sweetness. Making sure it doesn't trick us. Cool. Okay, so 71 degrees. So then we got this angle here. Oh, we have the side length. And so that's going to be 32 centimeters for little b. That's little b. And then they don't give us angle A, they give us little a, which is 33 centimeters, but we can find big A, which is opposite little a. And so using law of sines, faster, Newbold, faster. Okay, stop rushing me. So we have 32 equals, and then we have sine of A over little a, which is 33. Again, we'll go to multiply that 33 to the other side. That's a big 33, Newbold. Okay, stop complaining. So then we'll go to an inverse sine to the other side like that. And now we can find what that is, if it's even possible. If you get an error, it's not. Make sure you do it right. So we'll go inverse sine of 33 sine 71. Cool, close parenthesis. Then we'll make sure to divide that by 32, good. Close parenthesis. So now we have 77.2, round up to the nearest tenth. So if angle A is 77.2, Cool. And so now that's our other angle. So of course we can go ahead and do 180 minus those two now, right? So minus 71 and minus 77.2. And so now we have 31.8. So we have an acute triangle that works. Cool. So 31.8 degrees. Cool. But now what if we, so there's only one triangle. What if we swing that leg? Will that still work or no? Okay. So now we're going to go ahead and swing that leg down here. Okay. And so then as we swing that leg down to here, we're going to see, can you see it? We're going to see if we have, it's hard to draw, an obtuse triangle or not, right? So if that's 77.2, this is 77.2, and if this is 77.2, that means that, and this is 71 degrees, that we're going to go ahead and do 180 degrees, and minus the 77.2. And so we do have 102.8. So here's another triangle, 102.8 degrees. Awesome. So then that means we can go ahead and add that one, remember, with the given 71. And then do 180. Wow, that's going to be small. We can go ahead and 180 minus that answer. So now we have 6.2 degrees. So now this one is also, this is 6.2 degrees. Awesome. So now we have all our angles. No, don't say it, Nubel, please. I don't want to. You have to. So now they want us to find, this is angle C. They want us to find little c next and find all the sides and all the angles. So we're going to go C over. So now we're going back to the top one. It is two triangles, but they want you to solve them all. So now we're going to go C over sine 31.8 is equal to, we'll choose what they already gave to us, which we'll just use big B and little b. So 32 over sine 71, good. So all we got to do is multiply that sine 31, right, to the other side. We're going to multiply it to both sides, 31.8 to both sides. So then we get little c. Hallelujah. So little c then is equal to 32 sine 31.8, close parenthesis, don't forget to close parenthesis, divided by sine 71, good, good. And so that gives us 17.8. So we have 17.8. What's our measurement? Centimeters. Good, centimeters. So here we go. So we're going to make this worth lots of points to make sure you do it. And so we make each one of these parts a point. So here's 1 point. Awesome. So here's another point that we found right here. So there's 2 points. We found angle A, 77.2. That's 3 points. We found this angle, 4 points. That many? Yes, find them all. 5 points. Awesome. Remember that this is 32 centimeters from the given because this was little b. Remember? Little b. So then this one, they also gave us a 33. So now we just have to find one more. And that's this little c, or little c prime. So one last time. So c prime is what we're trying to find now. C prime. Optimus Prime. Transformers. Robots in disguise. Yeah, thanks for transforming with me. So then we're going to do the same thing. So little c over sine of, wait for it. So we have, where's the little c? Where'd you go? Oh, there you are. No, that's not it. Oh, we're trying to find little c. Over its angle. Whoa, 6.2? That's right. So this is c prime. So we're trying to find it. And so then we match it up with its angle, 6.2. So sine of 6.2. We can do hard things. Hang with me. Okay, and then we'll use the same, 32 over sine 71. So you got this. Probably just do it on your calculator. And then we'll times, remember, sine 6.2 to the other side. And then we're got this problem done. Nice. So then we got, some of the other ones will be easy. It's just one triangle that you solve. You're hoping. So then we got sine of 6.2. So 32 sine 6.2. Close parenthesis. Divided by sine 71. There we go. So that gives us c prime. Really small. That's good. So 3.6, 3.65. So 3.7. And so c prime then will be 3.7. 3.7 centimeters. Cool. Okay, so there's our 6th point. 1, 2, 3, 4, 5. 6 points. 6 points for number 7. Thanks for watching this video. You're welcome. Just got you 6 points. Okay, and as another way of saying thank you, we're going to let you look and get help from and make sure you're doing this right. So there's number 1 and number 3. It's going to only be one triangle. How come it's only one triangle, Newbold? Well, I think they did something with the height formula dealio, 180 minus, and I could talk about it in class too, but it looks like we're only going to get one triangle there. I think it has to do with the opposite side being 18 from the 69 degrees, and then little c right here. So the 69, so then if you have, I think it's a B. Yeah, there's your B. So B they give you is so small that this has to be really, really small angle, right? It's got to be a teeny, 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 teeny angle. And that means that one of these then has to be, and that's 69 degrees. So that means that's 69 degrees. One of these have to be really big and obtuse, so just one triangle. You can go more into depth there, but you can kind of get the idea because that side length is so small. There's our number 7 that we did together. Awesome. Looks like we did some rounding there from last year. Wow. There we go. So there's number 7. Number 9 again is going to be just one triangle. Find all the parts of the one triangle. And also number 11. Number 13, don't forget to do end behavior. You can just pause. I'm just kind of scrolling through, but you can pause. Out of 27 points. Pause it, Newbold. Pause it. You pause it. No, you pause it. You pause it. Okay. So definitely work on these ones and pause it to check your answers. And then do the evens ones as well. So thanks for watching, you behind the screen. Thanks for watching. Peace out.